In this video, we will introduce Content Provider's Query. Now we will implement and take a look at our query to return our data from our content provider. Here I have the query method. We override and implement the query method. The query method handles query requests from clients. This method can be called from multiple threads. Notice that I have a URI, a string array called projection, a string called selection, another string array called selection args, and a string for the sort order. Let's talk about these parameters. The URI to query. This will be the full URI sent by the client. If the client is requesting a specific record, the URI will end in a record number that the implementation should parse and add to a where or having clause specifying that ID value. Projection is the list of columns to put into the cursor. If not, all columns are included. A selection criteria to apply when filtering rows. If not, then all the rows are included. The string array selection args we may include as question in the selection, which will be replaced by the value from the selection args. In order that they appear in the selection, the values will be bound as strings, and that's similar to a prepared statement when we use JDBC. The sort order defines how the rows in the cursor should be sorted. If null, then the provider is free to define the sort order. Here I create and initialize a SQLite query builder, and my variable will be called QB. We use the SQLite Query Builder object. This is a convenience class that helps build SQL queries to be sent to the SQLite database objects. I call the method setTables and pass the constant of employee's table name. And we use the method setTables of SQLite Query Builder class, which sets the list of the tables to query. Multiple tables can be specified to perform a join. We perform a switch on the URI provided. Our first case sets up our SQLite Query Builder to use a projection map of the employees to obtain multiple employee records. SetProjectionMap method sets the projection map for the query. The projection map maps from column names that the caller passes into query to database column names. Case employee ID. This handles setting up our query to return a record by ID. We call the method appendWhere. The appendWhere method appends a chunk to the where clause of the query. All chunks appended are surrounded by parentheses and ANDed with the selection passed to the query. We use the method URI.getPathSegments, which returns a list. And we use get method with a 1 to get the second value. So here we are saying get the decoded path segments. It returns decoded path segments, each without a leading or trailing /. We use the get method of the list with a parameter of 1, and the get method returns the element at the specified location in this list. Every element in the list has an index. Each element can thus be accessed by its index, with the first index being 0. So here we are accessing the second element, which is our provider name. Finally, if no sort order is provided, we sort on employee name. Now we have a cursor object that we obtain by calling qb.query. So now we call a QB query to perform a query by combining all current settings and the information passed into this method. Now we're going to call the qb.query method. This will perform a query by combining all current settings and the information passed into this method. It returns a cursor over the result set. We call setNotificationURI to register to watch a content URI for changes. And finally, we return the cursor. This concludes our discussion of Content Provider's Query.